Hello everyone. So in this video, we will solve this set of problems. At the beginning of every problem, you will see the full question with a 3-second timer like this. I urge you, I beg you to pause the video when you see the timer and try to solve the problem yourself first. This will really help you become more independent and better at problem solving. There is another important reason. If you solve the problem independently, it will really expand your thinking. And sometimes you will witness that your solution is better, smarter than mine. And those will be proud moments indeed. Alright, let's get started then. Remember to pause the video when you see the timer. Each year, third Thursday in March is named Kangaroo Day. Right? Third Thursday. The dates of Kangaroo Day for the next few years are shown below with one error. Which date is wrong? Alright, notice that we have to check two things. It has to be a Thursday, but not just any Thursday. It has to be third Thursday, right? Okay, so what is the least possible date for a day to be third Thursday? Let me write down a quick calendar that will make it easier. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So the least possible date for a day to be Thursday is the first Thursday. First day of the month starts on a Thursday, right? And then the next Thursday will be plus 7, which is 8, plus 7 because there are 7 days a week. You can also count 1, 2, 3, 4, 5, 6, 7, 8, right? You can verify like that. And then the third Thursday will be plus 7 again, which is 15, all right? So this is the least possible date for a day to be third Thursday. Now, what is the highest possible date for a day to be third Thursday? In that case, the first of the month starts on a Friday, right? Then the next Friday will be plus 7, which is 8. So the Thursday will be the 7th. So this is the first Thursday. Second Thursday will be plus 7 is 14. And the third Thursday will be another plus 7 is 21. All right. So this is the largest possible date for a day to be third Thursday. So any other possible third Thursday must lie between these two numbers, 15 and 21. Let's check here. 17 is between 15 and 21. 16 is, okay, 17 is, 16 is, 14 is not between 15 and 21. 20 is, 19 is, then C must be the correct choice because that date doesn't even lie between these two dates. All right, if you noticed one thing here, actually in this case, I didn't even have to check if these dates are going to be Thursday, right? All that I had to check is if this is going to be a third whatever day, like it can be third Monday, third Tuesday, third whatever day has to be between 15 and 21. And in this case, this was the only choice that was not. So I was lucky that, C turned out to be the only choice that was not in between these two dates. And that was the correct choice. But what if this date was, let's say, 15th of March 2024? Then the first check that whether it has to be between 15 and 21 will work for all the choices. And then we have to also check whether it is going to be a Thursday. So let me show you that next. Okay, so in this case, I'm assuming that this is not 14. I'm changing the question. So let's say this is, or changing one of the choice. So this is 15th of March 2024. Okay, so this is the, now think that this is the question. Okay, now all the dates are between the 15 and 21, right? So we already checked that, so that is good. Now next, I should know how to calculate the number of days between these two dates, right? In a year, there are 365 days, right? So 365. If I went from 17th to 17th, that will be 365, but I'm going one less day. So minus 1, that is 364 days. All right. Now, what about from 15th to 16th to this 15th? So how many days will be there? Now, in this case, notice that 2024 is a leap year. Leap year meaning, the February has 29 days instead of 28 days, right? And the February falls in this date range, right? So February comes before March. So this will have 366 because leap year has 366 days. But I'm not going from 16 to 16. I'm going one less day. So 366 minus 1 is 365 days. Okay, now how about from 15th to this 20th? So there I have 365 days, right? If I went from 15 to 15, but I'm not going to 15, I'm going to 20. So I'm going to 5 more extra days. So plus 5. So this is 370 days. And here 20th to 20th will be 365, but I'm doing one less day. Minus 1 is 364 days. Okay. Now we know the number of days between these any two dates, right? And now how do I know which day of the week it will be? So one thing to remember is in a year 365 days, if I divide it by 7, because every seventh day is the same day of the week, right? So this is going to be the remainder is 1, right? That means if I take away 1 from there, 365 minus 1 is 364. So this number is going to be divisible by 7. So 364th day from today is going to be Thursday. All right, so actually today happened to be a Thursday. So let's say whatever day this was, 17th, if I go 364 days from there, we know that it is going to be the same day of the week, right? And it has to be a Thursday, right? It has to be a Thursday. Why? Because we know that at most one date is not going to be a Thursday. That is according to the question statement, right? Like third Thursday. So we already checked that everything is within that range of 15 to 21. So the first condition is satisfied. Now we are checking if which of this date is not going to be Thursday. And since there is only one correct answer, these both cannot be wrong. So these two have to be Thursday. Now, okay, this is so from here to here is 365 days. So if I went 364 days, I know that it is going to be the same day, Thursday, right? But I'm going one extra day. So this 15th is not going to be a Thursday, it is going to be a Friday, right? Because if I went 364 days, it will be a Thursday. I'm going one extra day. I'm going 365 days, so this is going to be a Friday. Okay. Now from Friday to from 15th to 20th. So 15th to 20th is going to be if I went 360. Okay. Another thing to note is if I add or subtract plus 7 or multiple of 7, it is going to be still divisible by 7, right? So if I add 364 plus 7 is 371. So 371 is also going to be divisible by 7. Now, from Friday, if I want 371 days, it will be a Friday again. But I'm not going 371 days, I'm going only 370 days. So I'm going one less day. So this is not going to be a Friday, this is going to be one less is Thursday. So this is going to be Thursday. Okay. Now, from here to here, 364 days, and we have already found out that if I go 364 days, it's going to be the same day of the week. So this will be Thursday again, right? This will go Thursday again. So in this case, only this is not going to be a Thursday, and then this would be the correct choice, right? In my changed question, right? All right. So I thought you should also know, like, if two dates are approximately 1 year apart, right? You should also know how to calculate the number of days and figure out which day of the week it will be. So I thought this will be helpful. Jenny looks at her weather app that shows the predicted weather and maximum temperatures for the next 5 days. Which of the following represents the corresponding graph of maximum temperatures? All right. So whenever you have to look at charts, remember two things. One is direction. Number two is magnitude. The direction is sometimes also known as trend, meaning is something going up or going down, and magnitude is the value, the number, right? Okay. Now let's go from Friday to Saturday. -1 to -2. That means it has to decrease. Here it is increasing, so this cannot be it. Here it is decreasing, this seems fine. Here it is increasing, it cannot be it, it needs to decrease. Here also it is increasing, it cannot be it, it needs to decrease. Here it is decreasing, it looks good. All right, next let's go to Saturday to Sunday. Saturday to Sunday, -2 to 0, so it has to increase. Most of the choices are already crossed out. I need to look at only these two, so it needs to increase. This is increasing, this is increasing, it's fine. 0 to 6, again it has to increase. Here it increases, here it is going down, so this cannot be it. So the only thing that is remaining is B, then B must be the correct choice. All right, so in this case, again, I happen to be lucky that I just need to check the direction. I didn't even have to check the magnitude. But let me give you another example. There, just checking the direction may not work. All right, let me just erase some of the marks. All right, this is a different example. Let's say this point was not here, but this point was somewhere here. And this point was somewhere here. The curve went like this and this instead of this one. Okay, so in this case, if we go from -1 to -2, it should decrease. It decreases here, it's fine. -2 to 0, it should increase. It increases here, fine. 0 to 6, it increases again, both are fine. 6 to 2 should decrease. It decreases here, it decreases here. So if we look the direction wise, both are still matching, right? Then next we have to look at the magnitude. What I'm doing here, you can do for all pairs, but let me just give one example. -2 to 0 is a difference of 2, right? So from this point to this point, let's assume this height is 2, okay? Similarly, from this point to this, height is 2, right? -2 to 0, the difference is 2, so that height has to be 2, this height has to be 2. Now, if that height is 2, next we are going from 0 to 6, so this is a difference of 6. So this is basically 3 times whatever this height is. This height needs to be 3 times, right? So if this is 2, if I go from here to here, as you can see, this height is roughly 3 times this height, right? Roughly 3 times this height, so this looks like that can be 6. However, now if I go from here to here, this height, we want this height to be 3 times this height, right? Because the difference is 3 times that difference. But this nowhere looks 3 times this height, right? Then this again cannot be the correct choice. This will still be the correct choice. But in this case, I had to look at direction as well as the magnitude, right? So in some questions, you may have to look at both, but always start with direction because that's easier to check. A park is shaped like an equilateral triangle. A cat wants to walk along one of the 3 indicated paths, thicker lines, from the upper corner to the lower right corner, upper corner to lower right corner. The lengths of the paths are P, Q, and R as shown, all right, P, Q, and R. Which of the following statements about the path is true? All right, so these are all equilateral triangles. Now, these 2 lines are parallel. That means this length is going to be the same as this length. So why don't I get rid of that length and assume instead that the cat is going this way. Similarly, let me get rid of this and assume that the cat is going like that. Similarly, let me get rid of that length and assume that the cat is going like this. Now, in all the 3 cases, the cat is always covering this distance, right? This is the same for all 3. What remains is to check these 2 lines, and these 2 lines, right? Now, if you look at, let's compare P and Q first. P and Q, so this line is same as this line, right? However, this would be Q is closer to the base, and as you can see, this is longer, right? Longer than this. Then Q has to be greater than P. All right. Now let's check Q and R. Q and R, this length is same as this length, right? But this length, right, is definitely bigger than this because this is closer to the base, right? We can also see it here, right? So again, Q is greater than R. Okay, so we know that Q is greater than both P and R. Let's check P and R now. If I look at P and R, this is the same. So this and this is the same. However, in this case, R again, this line is closer to the base than this one. R is greater than P because this length is closer to the base than this. Therefore, this is greater than this one. All right. So if you look here, Q is the greatest, right? And then R and then P. So Q is the greatest, then R, then P, then B is the correct choice. 6 rectangles are arranged as shown. The top left-hand rectangle is 6 centimeter, height is 6 centimeter. The numbers within the rectangle indicate their area in centimeter square. Alright, so these are the areas. What is the height of the bottom right-hand rectangle? So what is this side? Alright, so for a rectangle, area is base times height. So if I know any two of these three quantities, area, base, and height, I can always compute the other one. For example, here area is 18 and the height is 6. Area is 18, height is 6. Then B has to be 18 by 6. So B has to be 3. So the base has to be 3, right? Similarly, this base is common with this rectangle. So if the area is 12, the height has to be 4 because 4 times 3 is 12. Now, if we look at this rectangle here, this height is same as this, right? So this is 4. This has to be 4 then, right? So 4 times 4 is 16. That is this area. Now, let's take a look at this. The base is the same with this. So this height then has to be 8, right? Because 8 times 4 is 32, right? Now, here, this height is same with this both rectangles. So 8 times what is 48? 8 times 6. So the base has to be 6. This base has to be 6. So the 8 times 6 is 48. Now, if we look at this rectangle here, the base is 6. Height has to be 30 by 6, that is 5, right? 5. So because 5 times 6 is 30, so the height has to be 5, and then B is the correct choice. The halftime score of a handball match was 9-14. Thus, the visiting team was leading by 5 goals. All right. So this must be the visiting team. Okay. As a consequence of coach instructions received at halftime, the home team dominated the second half and scored twice as many goals as their opponents. Okay. They scored twice as many goals as their opponents. Okay. The home team won the match by 1 goal. Okay. They won by 1 goal. What was the final score of the match? All right, so 9-14. So this was the visiting team, this was the home team. You can solve this problem many ways. You can check each answer at a time and see which one makes sense. And then, another way you can do is, if for every goal in the second half the visiting team score, the home team scored 2 goals, right? And similarly, check, try 1 goal, 2 goals like that and see which one makes sense. But we will use algebra for this because number one, sometimes the choices may not be given to you. So algebra, if you can use algebra, right, that's a very powerful technique, and that makes the problem also a lot easier. So at this stage, at this level, I also want you to get used to using algebra. So we will use algebra. Okay. So what is given to us? Second, and score twice as many goals as their opponent. So if the opponent scored X, they must have scored 2x, right? And at the end, so the visiting team scored 14 plus x. Here, home team 9 plus 2x. But what is given to us? The home team won the match by 1 goal. So the home team has 9 plus 2x. So 9 plus 2x, right? That must be equal to whatever the visiting team, that was 14 plus x, but they won. So they scored 1 more goal than the visiting team, right? So plus 1. So whatever the visiting team scored finally, 1 more than that was the home team, right? So here I'll bring the unknowns to this side. So 2x minus x is, I take the 9 to the other side. So 9 So 14 plus 1 minus 9. So this is simply x. 2x minus 1 is x. So this is 15 minus 9 is 6. Right? All right. So what would be the final score? 9 plus x is 6. So 9 plus 12 is 21. And 14 plus x is 6. So this will be 20. Right? 14 plus x is 20. So the final score must be 21 to 20. B is the correct choice. And you can also verify they are one goal more than the visiting team. In a jazz band, Giuseppe plays the saxophone, Sergio plays the trumpet, and Eliana sings. They are all the same age. Okay, so those three are same age. There are three more members of the jazz band who are this many years old, respectively. The average age of the jazz band is 21. All right, average age. How old is Eliana? Okay, so G, S, and E, they are all of the same age. Let me call X. And there are three other members. They are 19, 20, and 21 years old. Here again, we will use algebra because it makes the problem a lot easier. And also at this stage, you should practice using algebra more often. So what is the average age? So I add up all the numbers and divide by how many numbers I'm adding, right? So this is 3x plus 19 plus 20 plus 21 divided by how many numbers I'm adding? 1, 2, 3, 4, 5, 6. So this is the average, and the average is given to us. The average of the jazz band is 21. So this is 21, right? All right. Then I have one equation, only one unknowns, fairly straightforward to solve. So 3x plus, okay, how much is this? So 20 plus 20 is 40, plus 1 is 41, plus 9 is 50, plus 1 is 60. So this is 60, right? So this is 60 is equal to 6 times 21. So this is 3x plus 60 is going to be 126. I take 60 to the other side. 3x is going to be 126 minus 60 is going to be 66, right? Okay, then x is 66 by 3 is 22, right? And okay, what is asking? How old is Eliana? Eliana, I have assumed she's x years old, so x is 22. C is the correct choice. 6 congruent rhombus, each of area 5 centimeters square, form a star like so. The tips of the stars are joined to draw a regular hexagon. X shown. What is the area of the hexagon? All right, what is the area of this hexagon? So for this hexagon, we already know the rhombus. There are 1, 2, 3, 4, 5, 6. There are 6 rhombus. We know the area. So what is remaining is to know the area of this white triangles, right? So somehow the area of this white triangle has to be related to the area of the rhombus, and we need to find out how. If you notice, let's say, let me call this angle x. So 1, 2, 3, 4, 5, 6. So 6 times x, they need to add up to 360 degree, right? 360 degree. That means x is equal to 60. 360 by 6 is 60. So this has to be 60 degree. All right. So if this is 60, this also has to be x. For the rhombus, the opposite angles are the same. But the total angle of the rhombus is 360 degree, right? If you take, actually, it doesn't have to be a rhombus. It can be any quadrilateral, right? And the sum of the 4 angles, actually you can divide it in 2 triangles, and each triangle 180 degree. So this is also 180 degree, the 3 angles, right? And they also add up to 180 degree. So total is 360 degree. Similarly, for the rhombus also it has to be 360 degree. And if I take 2x, x is 60 degree. So if 2x minus 2x, this is, so I'm trying to find out these 2 angles, right? Let me call this y, right? So, and this also has to be y then, right? Because they have to be the same angle, right? So this 360, if I take away those 2, this is to be 2y. I know x is 60. So this is 120. This is 120. So 360 minus 120 is so then 2y. 2y has to be 240, right? 360 minus 120 is 240. So that means y is equal to 120. So this angle is 120. All right. So if this is 120, this is the same angle. This is also y. These three angles again add up to 360. So what will be this angle? So 360 minus 2y, right? Y is 120 times 2 is 240. Okay. So 360 minus 2y is 240 because y is 120. So this is again 120, right? 120. So this angle is also 120. So this is same as y. Now, if you compare, half of this rhombus with this white triangle, right? They share the same side. This side and this side are the same because they are congruent rhombus, right? And this angle is also the same, right? So this triangle must be same as this triangle here. And we know the total area is 5, so this must be 5 by 2. All right, now we are set. So the total area of the rhombus is 1, 2, 3, 4, 5, 6. So there is 5 times 6, right? So this is the area of all the 6 rhombus together plus the white ones. How many of those white ones are there? 1, 2, 3, 4, 5, 6. 6 of the white ones, right? 6 of the white triangles, but each triangle is half of the rhombus, right? So 6 of those white triangles, but so this is again 30 plus 6. The triangle is half of rhombus, right? So 5 by 2 because the area of the rhombus is 5, so 5 by 2. So this is 3. Now 5 times 3 is 15, so 30 plus 15 is 45, right? Then C is the correct choice. A rectangle with perimeter 30 centimeter is divided into 4 parts by a vertical line and a horizontal line, like so. One of the parts is a square of area 9 centimeter square, right? As shown in the figure. What is the perimeter of the rectangle ABCD? ABCD, what is the perimeter of that? So this problem is actually fairly straightforward using algebra. So let's try that. So the area is 9 centimeter square and it is a square. So we know the side. Side will be square root of 9, which is 3. So this side will be 3, this side will be 3. So 3 times 3 is 9. Okay. Now, also given to us is the perimeter. To know the perimeter, we also need to know the x. So let me assume this distance is x. So then I know this length. And this is 3. So let me assume this is y, right? So let me write down the perimeter in terms of these numbers. So 2 times this side. So 2 times 3 plus x plus 2 times this side. 2 times 3 plus y. So that would be the perimeter in terms of x and y, and that is given to us, that is 30. Now area is in centimeter square. So square root of that is 3 is also in centimeter. So I'm just ignoring the units because everything is in centimeter. Now let me collect the variables together. So this is 2 times x plus y, right? So this is 2x and this is 2y. That is equal to 30 minus 2 times 3 is 6 minus 2 times 3 is 6. So this is 30 minus 12 is 18. So that is 2 times x plus y, right? So 2 times x plus y is 18. So what is 2 times x plus y? If this is x, right, this is also x, right? Rectangle. This is y. Like if this is y, this is y, right? So 2 times x plus 2 times y is nothing but this perimeter, right? We already found that out. 18. Then C is the correct choice. Ali drew 3 triangles on a grid. Exactly 2 of them have the same area. Exactly two of them are isosceles and exactly two are right angle triangles. Two of the triangles are shown, so these are the two. Which could be the third one? Which of the choice A, B, C, D, or E could be the third one? All right, so let me check the side and area of this. So this is 1, 2, 3, 4, 5. So this is the side of 5. 1, 2, 3, 4. This is side of 4. So the area is going to be half times 4 times 5. So this is going to be 10. So it has an area of 10. How about this? 1, 2, 3, 4. This side is 4. 1, 2, 3, 4. This side is 4. Area is half times 4 times 4 is going to be 8. So it has an area of 8. All right. So I know the sides and the area. Now, right away, I can see that the condition that two have to be right angle, right? So that condition is already met. This is right angle. This is right angle. So this condition is already met. What is remaining to check is same area and they are isosceles. So this is not isosceles. So this is isosceles. Okay. Now let's check which ones are isosceles, right? That's easier to check. This definitely doesn't look isosceles. So this cannot be it. This is isosceles. Okay, I will leave that. This is also isosceles. I'll leave that. This also is isosceles. I'll leave that. So this is 1, 2, 3, 1, 2, 3, 4. This is not isosceles, so this cannot be it, right? So we are left with three choices. Now let me check the area. What is the area of this? 1, 2, 3, 4. Base is 4. Height is 1, 2, 3, 4, 5, 6. The height is 6. So half times 4 times 6 is 12. So the area here is 12. That doesn't match with any area. So again, this cannot be it. Area is difficult to calculate, and anyway, it doesn't look like that will have the same area as this. So let me leave that. Let me try this. Here, I can take the height this way. 1, 2, 3, 4. So this is 4. Height is 1, 2, 3, 4. This way, height. So base is 4, height is 4. The area is, half times 4 times 4 is 8, right? So area is 8. That matches with this. Then D is the correct choice. Now, exactly two are right angle triangle. Those two are given. Two of them are isosceles. This and these are isosceles because, as you can see, this side and this side is same for this triangle. So this is isosceles. Okay, so this is met. And then same area. This says area of 8. This is area of 8. So again, D is the correct choice. The little kangaroo has chosen a special number. She gets the same result when she subtracts 110 from her number as she does when she multiplies by 110. What is her number? Alright, so this is another problem perfect for algebra. So let's try that. Let me assume the number is x. Okay. When she subtracts 110 from her number, so let me subtract 110 from that number. We get the same result when I multiply it by 110. So x times 110, right? So let me bring the like terms together. So this is x minus, x by 10. So x times 110 is just x by 10. So this is equal to, I'll take this 110 to the other side. This is 110. The negative becomes positive. This gives me 10. So this is 10x minus x is equal to 110. This 10 cancels out. This 10x minus x is 9x is equal to 1. So basically x is, I take the 9 to the other side, 1 over 9, right? Then is the correct choice. So when you use algebra to arrive at a result, oftentimes it is a good idea to just double check your final answer with the original problem statement just to make sure that you didn't make any mistakes. So let's do that. So let me do that. So we have x is 19 minus 110. So this is going to be, so this is 90. So 10 minus 9. So 1 over 90. Okay. So this is x minus 10. How about x times 1 by 10? So x is again 19 times 110 is equal to again 1 over 90. So we arrive at the same result, right? So that just to verify that we didn't make any mistake here. Tom had 10 sparkles of the same size. He lit one first. When only a tenth of it remained, he lit the second one. And when only a tenth of that remained, he lit the third one, and so on. Sparklers burn at the same speed along their entire length. One sparklers will burn in 2 minutes. How long did it take for the all 10 sparklers to burn down? All right. Only when a tenth is remaining, he lits the second one. So sometimes the problem becomes easier to solve or visualize, when you draw it out. So let me do that. So let's say this is the sparkler. The whole thing takes 2 minutes to burn down. When 1/10 is remaining, like here, so 1/10 of 2 is 0.2 minutes. This is 0.2 minutes. So this will be 1.8 minutes, right? 1.8 minutes. So this is 1/10, this is 9/10, right? When this is remaining, he leads the second one. Again, so this is 1.8 minute. And when 1/10 is remaining, he leads the third one, and so on and so forth. So this is again 1.8 minute. Finally, he is going to lead the last one, but the last one is going to burn the whole time, 2 minutes, right? So here, as you can see, you can just add it up. We start from here, go here is 1.8 minutes. Then next one starts, this is 1.8, again 1.8, and then at the end 2. So 1.8 times, how many 1.8s? 9, right? Because there are total 10. The last one burns for 2 minutes. So the whole thing is 9. 9 of this plus the last one is 2 minutes, right? So this is sometimes, if I express 1.8 as 2 minus 0.2, right, times 9, just it makes it easier to multiply. Instead of multiplying 18 with 9 plus 2. Now here I'll do one more thing. So 2 times 9, and there is another 2. So there is 2 times 10, which is 20, minus 0.2 times 9 is 1.8, right? Now, so 20 minus 1.8 is 18.2, right? So 18.2 minutes. So all right, so minutes and seconds. So what is 0.2 minute? 1 minute is 60 seconds, right? So 0.2 times 60 second. 0.2 is this is basically 12 second, right? So 2 times 6 is 12, and then there is a decimal point, so this is 12 seconds. So the total is 18 minutes and 12 seconds. Then B is the correct choice. Ahmad walks up 8 steps, going up either 1 or 2 steps at a time. There is a hole on the 6th step, so he cannot use this step. In how many different ways can Ahmad reach the top step? Let me draw the steps. 1, 2, 3, 4, 5, 6, 7, 8. Right? Number them 1, 2, 3, 4, 5, 6, 7, and 8. So there is a hole on the 6th step, so he cannot use this step. So he has to jump over like this. Okay. So 5 to 7 is a double step, which is fine. He can do that. But can he do 4 to 7? No, that would be a triple step. He cannot do that. 5 to 8. Again, he cannot do that. That would be a triple step. So only option for him is to get to the 5th step and take this double step here. And once he's at the step number 7, he can just do this single step, right? So he has to get to the 5th step, and once he reaches the 5th step, to go to 8, there's only one way. There's only one possible way from 5 to 8, and he has to get to 5. Now let's see how many different ways he can get to 5, from ground all the way to the 5th, right? He can take all single steps, 2, 3, 4, 5, right? Like this, from ground, 1, 2, 3, 4, 5. So this is one way, right? What are the other ways? He can take a double step and 3 single steps, but this double step can go in the beginning or here, or here, or here. So 1, 2, 3, 4 places it can go. Let me give an example. Let's consider this one. So he's first taking a single step and then taking a double step and then taking 2 single steps. Right? He reaches 5, they add up to 5. So here there is total of 1, 2, 3, 4, 4 ways. 4 ways like that. Next, he can take 2 double step and 1 single step. But again, this single step can go here, here, or here. So there are 3 different ways, right? Let me give one example here. Let me give this example. First, he's taking a double step. So he's going to 2 straight, and then he's taking a single step, 2 to 3, and then a double step, 3 to 5, right? So there are, how many ways this way? There are 3 ways. There are 3 ways like this, right? So you can take the single step either here, here, or here. That's 3 ways. Now, is there any other way we can combine ones and twos to get to 5? No, he cannot do 3 2 steps, right? This is already 6 steps, so he cannot. That is not possible. Then, so we have covered all the steps. So how many are there total? So here there is 1 plus 4 plus 3. So this is 8. So from ground to the 5th step, there is 8 possible ways, and for each of those 8 steps, there is only one way there. So 8 times 1 is still 8. Then the correct choice is C. The numbers from 1 to 6 are placed in the circles at the intersection of 3 rings, like so. The position of number 6 is shown, right? 6 is here. The sums of the numbers on each ring are the same, all right? The sums of numbers on each rings are the same. What number is placed in the circle with the question mark? What number goes here? Let me name the small circle lowercase a, b, c, d, e, and f, and the bigger circle uppercase A, B, and C. So let me write down this condition, right? So for A, what numbers are on A? A, D, E, B, A, D, E, B, and let's take me another circle B. What numbers are on B? B, C, D, F, B, C, D, F, and I'm told that they add up to the same. So this 4 number is same as this 4 number. They add up to the same number. Now in this case, I can cancel out D, take away D from both sides. What else? A, E, B. I can take away B too. So what is remaining is A plus E is C plus F, right? So this is 1. All right. Similarly, let me write down C, the other circle C. What numbers go on C? A, C, E, F, A, C, E, F. Okay. Let me write down one of these circles again. I can choose either one. I'll just choose A, D, E, B, A, D, E, B, and again. So these 4 numbers add up to same as these 4 numbers. I can take away A from both sides. I can take away E from both sides. So this leaves me C plus F. C plus is D plus B. D plus B. All right. So let's try to look at these 2 equations, right? A and E. So this is A. This is E. That is same as C plus F. That is C, F, and C plus F is same as D plus B. It is D, it is B. Okay. So as you can see here, there are 3 pairs of number, right? That the numbers are from 1 to 6. 1, 2, 3, 4, 5, 6. The number of from 1 to 6, and I have to divide this in 3 pairs such that each pair is the same. They are up to the same. Now the way I can do is I can find the total sum. Total sum is, as you know, the sum of consecutive numbers from 1 to 6 is 6, the last number, times the next number by 2, right? So this is 3, so 21, right? So the numbers from 1 to 6, they add up to 21. I have to divide them in 3 pairs. So each pair will have 21 by 3 is equal to 7. So each pair needs to add up to 7. So each pair needs to add up to 7. That means 6, right? 6 must go with 1. 6 must go with 1, right? The other 2 pairs must be then, 4 plus 3 is 7, and then 2 can go with 5. 2 can go with 5, right? Now, we already found it out. 6 goes with 1, 6. So this C must be 1 then, right? Then A is the correct choice. 2021 has remainder of 5 when divided by 6, 7, 8, 9. How many positive integers less than 2021 have this property? Alright, so we have to find some numbers such that if I take away 5 from those numbers, that will be divisible by 6, 7, 8, 9. So basically we need to find multiples of 6, 7, 8, 9. And how do we do that? As you can already see, this problem is screaming LCM, right? So let me try to find the LCM of 6, 7, 8, 9. LCM will be, first I'll divide by 2. So this will be 3, 7 will remain as it is. This will be 4, 9 will remain as it is. And then I'll divide by 3, 1, 7, 4, 3. Okay, that's it. Now I need to multiply all these numbers. 2 times 3 is 6, times 7 is 42. 42 times 4 is 168, times 3 is 504. All right, so this is the LCM of 6, 7, 8, and 9. Now, okay, so LCM is 504, and I need to take multiples of that, right? So let me do it like this. Let me take the first multiple. So first multiple of LCM is 504. Then I need to add, because I need a remainder of 5, right? So I need to add 5. It will be 509. So this will be a number that will satisfy this property. 509 has a remainder of 5 when divided by 6, 7, 8, 9. I know that because that's how I have found that number. All right. I can also next I can take the second multiple of the LCM. So 2 times 504 is going to be 1008, and then I add 5 because I need a remainder of 5. So this is going to be 1013, right? So again, 1013 has a remainder of 5 when divided by 6, 7, 8, 9, because that's how I have found that number. How about I take the third multiple of the LCM? So this is going to be 1512 plus 5 is 1517, right? So again, 1517 will have that property because that's how I have found it. How about I take the fourth multiple? Fourth multiple of the LCM. So that is going to be 2016 plus 5. This is going to be 2021, right? So 2021, and that is already given to us, right? We already know 2021 satisfies this, but we need to find positive integers less than 2021. So I cannot count this. So what's remaining is 1, 2, 3, right? So 3 is the correct choice for this, right? No, wrong. 3 is not the correct choice. Now, this is a good time to pause the video and try to figure out where I went wrong. All right, I hope you were able to figure out my mistake. Now, if you're still thinking, you know, I should have counted 2021. No, I cannot count that, right? I need to find the integers that are less than 2021. But I forgot the zeroth multiple, right? Zeroth multiple of LCM is going to be 0, right? And I add 5 to that, 5, right? So 5 will be another number. In fact, that will be the smallest positive integer that has a remainder of 5 when divided by 6, 7, 8, 9. Obviously, right? If I divide 5 by 6, 7, 8, or 9, the remainder is going to be 5. So that also satisfies that. So basically, I forgot the zeroth multiple. Then I have total of 1, 2, 3, 4. So then A is the correct choice. The figure shows a semicircle with center O. Two of the angles are given. All right, and these two. What is the size in degrees of the angle alpha? All right, so what is this angle? Alpha. Okay. So this is a semicircle. Now, this is actually an inscribed triangle. This, the triangle with these vertices, right? So what is an inscribed triangle? Inscribed triangle is such that all the three vertices lie on the circle, right? So this is also an inscribed triangle, right? Now there is one nice property of inscribed triangle, and that is if one of the sides of the triangle happens to be the diameter of the circle, right? So no matter where the other vertex is, right? So this is also an inscribed triangle because all the 3 points are on the circle. But this is a special inscribed triangle. One side is the diameter of the circle. Then this angle is always 90 degrees. Always. So if you remember that, this problem becomes very easy. If you don't remember that, let me just give a quick proof. So let me draw it again. So this is the diameter, and let me draw the inscribed circle like this, triangle like this. I'll join this here. This side is same as this side, is same as this side, because they are all the radius of the circle. Let me call this angle A. This length is same as this length, so this is isosceles triangle, so this angle also has to be A. This length is same as this length, so this angle, if this is B, this also has to be B, right? Then if I add the angles of this triangle, this bigger one, that is 2A plus 2B, they must add up to 180 degrees, right? The three angles of a triangle, they add up to 180 degree. So basically A plus B is 180 over 2 is 90 degrees. But what is A plus B? A is this, B is this. So that is the inscribed angle, right? That is the same. This is the this angle. So this always ends up to be 90 degree, no matter where this point is, right? All right. Then this is going to be 90 degree. This is 90 degree. Okay, that's one thing to note. Now, so if this is 90 degree, if I look at this triangle here, right? If I look at this triangle, these two angles would add up to 90 degree, right? The whole thing is 180 and this is already 90. So if this is 67, this is going to be 90 minus 67 is 23. Okay. Now, if I look at this triangle here, this is an isosceles triangle, right? So let me just change the color. So this side is same as this side, length are the same, they are the radius, right? So if this is 23 degree, this has to be 23 degree too. All right. Now, one more thing. This is also an isosceles triangle, right? So this side is same as this side. Then this angle has to be same as this angle. So this also has to be 32 degree, right? Then what is alpha? The angle alpha is this, which is 32, minus this one, right, which is 23. So 32 minus 23 is 9, right? Then A is the correct choice. In a team competition, there are 5 teams waiting to start. Each team consists of either only boys or only girls. The number of team members are 9, 15, 17, 19, and 21. After all members of first team have started, the number of girls not started yet is 3 times the number of boys not started yet. All right, girls not started yet is 3 times the boys not started yet. How many members are on the team that have already started? All right, so we need to find out the team that has already started, how many members are there. All right, so let me assume that G is the number of girls that have not started yet, and B is the number of boys that have not started yet, right? Then what is given is G is equal to 3B, because number of girls not started yet is 3 times the number of boys not started yet. Okay, then what is the total number of people that are remaining? That is G plus B, but G is 3B, so G is 3B. 3B plus B is 4B. All right. Let's try to think about what that condition means, right? Let me start with an example. So the team members are 9, 15, 17, 19, 21. Let me assume that this team has already started. I don't know that yet. I need to figure that out, but I'm just assuming. Then the number of people that are remaining, that needs to be a multiple of 4. That's what it means, right? So the total number of people remaining after the first team has started needs to be a multiple of 4. That is the first condition. Total multiple of 4. Total should be a multiple of 4. This is the first condition. All right. Now there is another condition hidden in there. If I divide the total number of people that have not started by 4, right? So I end up with B, right? So that is the total number of boys that have not started, right? Now that needs to be, so either one of the remaining groups needs to be that number B, or one or more of the groups need to add up to that number B, right? Because a group has only boys or girls. So either one of the numbers needs to be that B, or few of the groups, they need to add up to give me that number, right? So that is the second condition. Total by 4 should be B. Okay, so let me find the total here. 19 plus 21 is 40. Here 15 plus 70 is 32. So 32 plus 40 is 72, right? Now 72 is a multiple of 4. Okay, so let me divide 72 by 4. So this gives me 18, right? So the first condition is satisfied. Total is multiple of 4, and if I divide by 4, I get 18. So total by 4, which is 18, should be B. So one group here should be this number 18, right? Or few of these groups needs to combine to give me 18, which is not, right? None of these groups are 18, right? Or I cannot combine one or more group to get me 18. So the second condition is not satisfying. Then this group cannot have started. So A is not the correct choice. Now let me try this one. Let me write down the numbers one again. 9, 15, 17, 19, 21. Now I'm assuming that this group has started, right? I sum it up again. So this is 40, right? 9 plus 17 is going to be 26. If I add it up, so this is 66, right? 40 plus 26 is 66. Now 66 is actually not even a multiple of 4, right? It is not a multiple of 4. So again, 15, the group with 15 cannot have started, right? So again, B is not the correct choice. Similarly, actually, you can check C and D. I have already done that. I'll spare you some calculations here. We'll go straight to E. Okay, let's check E. Let me write down the numbers one more time here. 9, 15, 17. So 9, 15, 17, 19 and 21. 19 and 21. And this time, I'm assuming that this group has already started. Then if I sum up these two numbers, so this is going to be 24, right? And this is going to be 36. So 24 plus 36 is, so these two together gives me 60, right? So 60 by 4, 60 is divisible by 4, and 60 by 4 is 15, right? Now, so the first condition is already satisfied. It's a multiple of 4, right? And when I divide by 4, I get 15. Now this should be one of the groups that is remaining. And yes, it is in fact one of the groups that is remaining. Then this group must have started, right? Then E is the correct choice. 5 cars participated in a race starting in the order shown. All right. Whenever a car overtook another car, a point was awarded. The cars reached the finish line in the following order. What is the smallest number of points in total that could have been awarded? All right. So let me write down the cars. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They are in order. And I want to arrive at this configuration. I see that number 2 is in the front. The 2 needs to go here. So it needs to overtake 1, 2, 3 car, and for each car it overtakes, I get a point. So 3 cars it overtakes, I get 3 points. All right, so 2 is gone there. So I'm left with 1, and then 3, 4, 5, and 2 is in the front now. Okay, now I need 4 behind 2. So 4 needs to go here. It needs to overtake 1 car. For each overtake, I get 1 point. For 1 car, I get 1 point. Okay, so 4 is gone there. So I have now 1, 3, 5, and then 4 is next, and then 2. Okay. So I have 2 in the front, then 4, and then I need 1 next, right? I need 1 to be here, right? And then I need to overtake how many cars? 2 cars, right? I need to overtake 3 and 5. So I need to overtake 2 cars here. Then I'm left with 3, 5, 1, 4, 2. 3, 5, 1, 4, 2. 3, 5, 1 goes there, 4, 2. All right. Now I have 2 in the front. Next is 4. Next is 1. I need 5 next. 5 is already there. 3. All right. So I have all the cars in order. So the total number of overtakes is 3 plus 1 is 4 plus 2 is 6. For each overtake 1 point. So I get 6 points is the correct choice. A 3 by 3 square initially has the number 0 in each of its cells, like this. In one step, all 4 numbers in one 2 by 2 subsquare, such as the shaded one, for example, are then increased by 1. Okay. This operation is repeated several times to obtain the arrangement on the right here. Unfortunately, some numbers in this arrangement are hidden. What number is in the square with the question mark? All right. So what is the number here? Okay, so let's try to follow the steps. First thing we can see is this number is 13. So this number comes only within this square. So let's increase everything by 13. So this will become 13, 13, 13, 13. Okay, so this is already taken care. This is already done. I need 18 here. This 18 can be with this square or this square. So let me choose anyone. Let me choose this one. Then I increase every cell in the 2 by 2 by 1, right? So if for this to be 18, from 0 to 18, everything needs to increase by 18, right? So 18, so 13 plus 18, 13 plus 18, because there was already 13 there, right? So I have to increase by 18 more. All right, so this is done, this is done. I need a 47 here, but how much I have? 13 plus 18. 13 plus 18 is 31. I have 31, but I need 47. 47 minus 31 is 16. So I need to increase this cell. So I need now to increase this cell, all the subsquares, by 16, right? So plus 16 plus 16, 0 plus 16 is 16 anyway. So plus 16 and 16 here, right? And then I'm set. So there is 18 here, so which is fine. 13 plus 18 plus 16 is 47. We already, in fact, that's how I started. And then I end up with 16 here, right? Then C is the correct choice. All right. One question you may have here is, first I took care of this cell 13, and then I went to 18, right? Why not 47? So let me try that. Let me draw it again here. So first I want to take care of 13. That makes sense because the 13 can go with only this square. There is no other choice. So 13, 13, 13, 13. Now, instead of taking care of this 18, let's try to take care of the 47. So if I want 47 there, I need 34 more, right? So then plus 34, and then this will go with this cell, right? Plus 34, 34 plus 34. Okay. Now this gets me 47, right? So this gets me to 47. So 47 is taken care, 13 is already taken care, but I need an 18 there, right? Now for me to get 18 there, I have to increase these 4 or these 4. In either case, I have to increase this, but this is already at 47. I cannot increase this anymore. So I cannot get this 18 if I go this way. If I first try to do 13 and then 47 and then 18, right? That's why I first did 13 and then 18, then 47. What is the sum of 6 marked angles in the picture? All right. So this is actually an easy problem if you realize that these marked angles are the interior angles of a polygon. And if you know the formula for the sum of interior angles of a polygon. But if you don't know the formula, no worries. I'll quickly derive it here. Let me just draw any polygon here. You can take a point and then just join the corners. Basically, I'm making triangles, dividing the whole polygon into triangles. So, and I know the sum of angles of a triangle is 180°. So this plus this plus this is 180°. And how many triangles I have? 1, 2, 3, 4, 5. How many ever sides are there, right? So 5 times 180. So that is the sum of all the angles, right? All the angles, right? Okay. Now, to get the sum of only the interior angles, right? Only the interior angles, I have to subtract this away, right? So minus 2 times 180, because this is 360°, which is 2 times 180. So this is basically 5 minus 2 times 180. What is 5? 5 is basically n, number of sides, right? How many other sides are there? 1, 2, 3, 4, 5. So if a polygon has 10 sides, it's 10 minus 2, so on and so forth. All right. So in this case, if you notice, let me assume these are the interior angles. Let me count the number of sides. Let me start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10-sided polygon. So that is 10 minus 2 times 180. So that will give me the sum of interior angles of this entire polygon. But I don't need this, right? So these I have to take away. These are the 4 right angles. 4 right angles. So minus 4 times 90, right? So I have to subtract this away, right? So is the sum of this is the sum of all the interior angles of this 10-sided polygon, but I don't need these 4 right angles. So I'm subtracting that away. So this will come down to, this is 8 times 180 minus this will be 4 times 90 is 2 times 180, right? 2 times 180. So if I apply the distributive property, this is going to be 6 times 180. So 6 times 180 is so this is going to be 0, 1080, right? Then C is the correct choice. There are 8 boxes in the strip shown. Numbers as in adjacent boxes have some A or A plus 1 as shown. All right. The numbers in the first box and the 8th box are both 2021. What is the value of A? All right. We need to find the value of A. Let me actually number these boxes: 1, 2, 3, 4, 5, 6, 7, and 8. So box number 1 is 2021, that's given to us. Box number 2, the sum is given, so we'll try to propagate, right? Basically that's the idea. 2, the 2 will be, we know that this cell plus this cell is A, so this will be A minus this, right? So there is A minus 2021, right? This will be, this together are A, so A minus 2021 will be 2. All right, and then what will be 3? 3 will be this sum is A plus 1 minus whatever is this, cell 2. Cell 2 is A minus 2021, right? A minus 2021. Now if I open this bracket, so this 2 will cancel out, so this is going to be 1 plus 2021, so this is going to be 2022, right? All right, similarly we'll keep propagating. 3, okay, 3 is already done, so 4, 4 I can take it from here. So 3 plus 4 is A, so 4 is basically A minus 3, and 3 is 2022, right? So there is A minus 2022, that's it, right? Okay, next is 5. What is 5? 5 plus 4 is A plus 1, so 5 will be A plus 1 minus 4. 4 is A minus 2022, and this gives me this A, and A will cancel out, so 1 minus minus plus 1 plus 2022, there is 2023. All right, so that's 5. Now 6, I know that 5 plus 6 is A, so 6 is going to be A minus this 5th cell, which is 2023. All right, so that is 6. 7 plus 6 is A plus 1, so there is then A plus 1 minus whatever is 6, and I have already computed that to be A minus 2023, right? Again A cancels out, so this gives me 1 plus 2023 is 2024, that is going to be 7th cell. Now the last one, 8, this plus this is A, so this is going to be, so 2021 is going to be A minus this, A minus this 7th cell, that is 2024. So this tells me, A, I'll bring this 2024 this side, so that is 2021 plus 2024. I did a 5404045 is the correct choice. An ant climbs from C to A on path CA and descends from A to B on the stairs as shown in the diagram. All right, so on the stairs, what is the ratio of the lengths of the ascending and descending paths? All right, what is the ratio of the ascending and descending paths? All right, now there are few things to notice here. If I add up all these lengths, right, this length, that is same as if I draw a perpendicular line from here, right? So these lengths all add up to this length, and this is a perpendicular, right? Similarly, if I add up all these lengths, that will add up to this length, right? There is something to notice here. Okay, now a few more things. If this is 60-degree, and if I look at this right triangle, this must be 30-degree, right? 60 plus 30 is 90, and this is 90. Now if this is 30, this must be 45, because the total is 75 that is given to us. Now if I look at this right triangle, if this is 45, this must be 45-degree, right? Now again, if you notice, so this is a isosceles right triangle. So if I call this height to be h, this also will be h, right? All right, so we have figured out few things about this diagram. Now let's try to write the ratio of ascending. Let me call this ascending path A. So A over descending. So descending is this staircase, but we just figured out that the staircase is nothing but going like this and like this. So there is h plus another h. So there is A over 2h, right? Okay, I want to do a little bit more simplification to that. So this is nothing but 1 by 2 times A over h. This is nothing but 1 by 2 divided by h over A. So I'll tell you why I'm writing like this in a bit. In fact, this is why I'm writing like this. What is h over A? So if this is 60-degree, h over A is nothing but sine of 60-degree, right? So I think at this point you know about trigonometry. That's why I'll go ahead and use that. And so that is sine of 60-degree is the height divided by the hypotenuse. Then sine 60-degree is how much? Sine 60-degree is square root of 3 by 2. This is another thing to remember. But if you don't remember, let me quickly derive that actually. So that's fairly easy to derive. So let me take this is a equilateral triangle. So all sides are the same. Now let me draw a perpendicular. So if this is A by 2, right? Because this is a perpendicular and this is an equilateral triangle. So this has to be half of the whole length. Let me call this h. So if I apply Pythagoras theorem, again this is right triangle, there is h square plus A by 2 square must be this square, A square. So that is h square plus A square by 4 is equal to A square, or h square is equal to A square minus A square by 4. I'm taking the square by 4 to that side. So this gives me h square is equal to 4a square, 4a square minus a square by 4. So h square is equal to 4a square minus a square is 3a square by 4. If I take square root both sides, h is equal to square root of 3a by 2. All that I'm doing is taking the square root both sides, right? And then I bring a to this side. So h over a is equal to square root of 3 by 2. What is h over a? H over a is, okay, so this is an equilateral triangle, right? That's what I had started with. So this is 60-degree. This is 60-degree, this is 60-degree, this is 60-degree, right? All right. So what is h over a? H over a is nothing but sine 60-degree, right? Then, so this is equal to sine 60-degree, right? So this is something to remember, but if you don't remember, you can very quickly derive it. Okay. Now let me continue this simplification here. So this is half divided by sine 60-degree. Sine 60-degree is square root of 3 by 2. square root of 3 by 2. So this is half times 2 by square root of 3. 2 cancels out. So 1 over square root of 3. All right. So the ratio that I want is this, which is same as 1 by square root of 3. And if you look, nothing matches, or so I thought, But if you look very carefully, what is this value, right? So this is basically square root of 3 by 3 is square root of 3. I can write 3 as square root of 3 times square root of 3, right? So square root of 3 times square root of 3 is 3, and this cancels out. So this is basically 1 over square root of 3, right? So sometimes, you have to be a little bit careful. The final answer that you get may not exactly match, but you may have to do some simplification. So essentially, this is same as this, right? Then E is the correct choice. The numbers A, B, and C satisfy this and this. What is the value of? All right. If you are a bit observant here, then it's actually an easy problem to solve. A plus B plus C is 0. Then what is A plus B? A plus B, if I take C to the other side, then it's negative C, right? So A plus B is negative C. Similarly, B plus C will be negative A. C plus A will be negative B. Now, if I multiply minus C, minus A, minus B, there are 3 negative signs. So finally, it will be a negative A, B, C, right? A, B, and C. But ABC is 78. So ABC is 78, right? So the whole thing is then negative 78, right? Then the correct choice is B. Let n be the smallest positive integer whose sum of its digits is 2021. What is the sum of the digits of n plus 2021? I will start with a simpler example to explain the concept. Then we'll come back to this problem. Let's say I want to find the smallest positive integer whose sum of digits is 20. Just 20, right? So I can start writing any integer. Let's say 2, 3, 7. 7 plus 3 is 10 plus 2 is 12. I need 8 more, 8, right? Yeah, so the sum of the digits add up to 20. 2 plus 3 is 5, plus 7 is 12, plus 8 is 20. So the sum of the digits add up to 20. But can I do better than this, right? Somehow, if I can reduce the number of digits, right, that will be a smaller integer. Remember, the smallest 3-digit integer is always greater than the largest 2-digit integer, right? So if I can reduce the number of digits, the integer will be smaller, right? Because we want to minimize this integer. Now if I want to minimize this integer, I want to use the biggest 1-digit number, which is 9. So I want a 9, right? Can I use more 9s? Yes, I can use another 9. So 9 plus 9 is 18, and then 2 is remaining, and then a 2. Okay, so I can use 2 9s and a 2. So that they together, 9 plus 9 is 18, plus 2 is 20, right? But then another question is, how do I arrange, right? I want the smallest on the left side, right? So 2, 9, 9, and because of the place value, this will be the small. And also we can see 992 is bigger than 299, right? So this is the smallest. So basically, this is going to be the smallest integer whose digits add up to 20, right? All right. So this is the main concept. Basically, we want to see how many 9s I can take from here, and then what is remaining, right? So now let's look at the original problem. I'll use the same concept. So 20, 21, how many 9s are there? So this is going to be 2, 2, 4, and the remainder is 5, right? So remainder is 5. So I'll have 224 9s. So 9, 9, 9, 9, 224 of those, and then 5. This remainder we want on the left hand side. Remember, we want that on the left hand side. Okay. Now, so this is the smallest positive integer whose sum of digits is going to be 20, 21. Okay. Now I want to add 20, 21 to that. Okay, so let me write down some ending 9s. Okay, and I want to add 20, 21 to that. Now if I just add it up, 9 plus 1 is 10, carry over 1. 9 plus 1 is 10, plus 2 is 12, carry over 1, plus 9 is 10, carry over is 1. 1 plus 9 is 10, plus 2 is 12, 1. So there are a few more 9s here. So carry over is 1, plus 9 is 0, carry over is 1, and that 1 is going to carry over all the way. So these are going to be all zeros here. 9 plus 1 is 0, and that carry over will be 1 here. 1 plus 5 is 6. So as you can see, I have bunch of zeros there, and the only thing non-zero are the 6, 2, and 2. So 6 plus 2 is 8, plus 2 is 10, right? So the sum of the digits of n plus 20, 21 is going to be 10, and then A is the correct choice. 3 boys played a word game in which each wrote down 10 words. Each boy scored 3 points if neither of the other boys had the same word. Each boy scored 1 point if only one of the other boys had the same word. No points were awarded for words which all 3 boys had. When they added up their scores, they found that they each had different scores. So each had different scores. Sam had 19 points, which was the smallest, and James had the highest score. How many points did James score? All right. We actually need to just try out a few things here. Let me denote U as the number of unique words, D as duplicate, it has duplicate with one other person, and A meaning all had the same word. Okay, I want to somehow see how can I get 19 points for Sam, right? I start with, if he got all 10 unique words, he would get 30, right? And 0 duplicate and 0 all had, because they all needs to add up to 10. Then he would get 30 points. That is too much. How about he had 9 unique, right? And whatever these numbers, so let's say 0 duplicate and 1 all had, so this is still 27. That is still too much. I want to get to 19. So all the way 8 will also give me, no matter what this had, this will be 24. That's again too much. 7, whatever this is, will give me 7 times 3. So this is times 3, this is times 1, this is times 0, right? So 7 times 3 is 21. That's again too much. How about 6? If I have 6 unique, 6 times 3 is 18, okay? And then he can have 1 duplicate and 3 that all had. So that adds up to 6 plus 1 is 7, plus 3 is 10. This gives me how many? 6 times 3 is 18, plus 1 times 1 is 1. So 18 plus 1 is 19, and this gets 0 point anyway. So this is one way to get 19. How about if he had 5 unique words? So if he had 5, so he would get 15. 5 times 3 is 15. And then he needs to get 3 more with duplicate with one other person, right? So this 5 times 3 is 15. Sorry, he needs to get 4 more, right? 4. So 5 times 3 is 15, plus 4 is 19. And then he had 1 common with everybody. So there's 5 plus 4 is 9, plus 1 is 10. So the total number of words add up to 10. and he gets how many points? 5 times 3 is again 15, plus 4 is 19 points. What if we had 4 unique cards? So 4 times 3 is 12, and even if he gets all 6 as duplicate with other, 12 plus 6 is 18, right? So maximum he can get is 18, so this is not going to work. So these are the only two possible choices that Sam could have had, right? He could have gotten either 6 unique or 5 unique. So these are the only two possibilities. So let's try to check each one of those now. So Sam, let's say I'll write U for unique, D for duplicate, A for all had that. Let's say he got 6 unique, 1 duplicate, and 3 that all had. So the other two person, if he had 6 unique, so everybody had 3, right? 3 was the same for everybody. So the maximum the other two person could have gotten unique is 7 and 7, right? Because 3, everybody had 3, right? So in this case, and he had duplicate with 1. So let's see, let's say this is James. I will try to maximize that. Let's say the duplicate one was with this. So so in this case, it will not be 7, it will be 6 unique and 1 duplicate, right? So in this case, you get 6 times 3 is 18, plus 1 is 19 points. But this is same as Sam had, right? But they all had unique points. So this cannot be it. So this way we cannot get. So 6, 1, and 3 is not going to work. Let me try the other one. Let me erase this. Okay. So 5, 4, and 1. You get 5, 4, and 1. Okay. If we had one card that everybody had, the maximum unique they could have had is 9, right? So this is unique and duplicate. So this is the James. I'll try to maximize this. Maximum unique you could have had is 9, because 1 is, everybody had 1. So if he had 9 unique, there is 4 duplicate with one other person. So let me give that duplicate to here, so that I want to maximize James' number. So if there was 4 duplicate here, right? So if there's 4 duplicate, then unique must be 5, right? Unique number of unique cards must be 5. So 5 plus 4 is 9, plus 1 everybody had, that is 10. So in this case, 5 times 3, for each unique they get 3 points. 5 times 3 is 15, plus 4 is 19. Again, that is the same as what Sam had, right? So that is also not going to work. So he could not have had all the 4 duplicates with this person. So maybe he had 3 duplicate and 6 unique, right? So I'll give the other duplicate. There needs to be 4 duplicate with 1, right? So I'll give the other duplicate to here. So if James had 1 duplicate, then he would have had 8 unique. The total add up to 9, because 1 card they had common with everybody, right? So in this case, 6 times 3 is um, 18, and then this gets 1 point each, so there is 3 points. So 18 plus 3 is 21. All right, so this is a different score. Now in this case, 8 times 3 is 24, and this gets 1 point, plus 1. 24 plus 1 is 25. All right, now I'm getting somewhere. So Sam has 19 points, this person has 21 points, and James has 25 points. So they all had different scores, right? They all had different points, so that condition is satisfied. Sam had the lowest, because 19 is the lowest among 19, 21, and 25, and James in this case is highest, and that must be 25, and that is the only option that is left actually, out of different possibilities, right? So James must have had 25 points, and he is the correct choice. the smaller square in the picture has area 16 and great triangle has area 1. What is the area of the larger square in centimeter square? Actually, unit is not given to us anywhere else, so I'm just assuming the lengths are also in centimeter. Now, sometimes, when you want to find an area, you will see that it is easier to add and subtract different areas to get at that area. And sometimes it is just easier to use the raw formula for the area. In this case, I have tried it and it turns out we just want to use the raw formula. So area of this small square is given to us, that is 16. So let me call the side length as A. Then area of the smaller square is simply A square, is 16. Then area of the great triangle, it is the great triangle. Let me denote that area as the triangle symbol, and that is given to us as 1. We want to find the area of the larger square. So let me call the side length of the larger square as B. So we want to find basically B square, right? Area of the bigger square will be B square. One thing I can quickly notice that this angle is also 90 degree, right? So then I can use the Pythagoras theorem. So B square is equal to, so this is also, if this is A, this also is A, right? This is the side of the same square. So that is A square plus this length here. Let me call this length C, right? It is C square. So that is the area for the bigger square. But A square I already know to be 16, right? So this is already known to us. So this is 16. What is remaining is to find out C square. So somehow this C square has to be related to the area of the triangle, right? Okay. Now, if you look here, C is nothing but the base of this triangle, right? Now, what is the area of the triangle? Formula: half times base. Base is C, because that's what I have assumed this to be C, times height. Okay, let me draw in height here then. Height. So this is 90 degree, and let me call that height H. So I'm just calling that height H. Okay. Now somehow I have a feeling that I know the area and I need to find C in terms of the area. So somehow H has to be related to C, and we need to find out how is that related, right? Now if you look carefully, let me change the color. Let's take a look at this triangle here and this triangle. Okay, let's take a look at those two triangles. If this side is B, this is also B, because that is also the side of the same square, right? And this is a right triangle, this is also a right triangle. How about, okay, another thing to notice is this is also 90 degree, right? Because this is the one interior angle of the square, right? So this is a square, this is the interior angle, this is 90 degree. Now this angle here plus this angle, let me call it X, is 90 degree, right? It's 90 degree. But this angle plus this angle is also 90 degree, because those are the other two angles of the triangle. That means this angle has to be same as this angle, right? This angle here is same as this angle. Now, if you compare these two triangles, they are congruent because they have the two angles same, 90 degree, 90 degree, and these two angles are same. And then they have one side same, right? So for a triangle, if three independent things are the same, then they are congruent, right? That means if this length is C, that's what I have assumed, this is also going to be C, same length, right? So H basically is equal to C, right? So H is equal to C, and now I am all set. So the triangle area is 1 is equal to half, right? Half C square. C times C is C square. So this tells me that C square is equal to 2. C square, I take 2 to the other side. So C square is equal to 2. I just substitute that here. Now 16 plus 2 is 18, and that's what I'm looking for, right? B square is equal to 18. Then B is the correct choice. One thing that comes often handy is, let me draw a right triangle here. Okay, so this is a right triangle. If I draw a line perpendicular to this, right, so this is 90-degree, right? So let me call this angle A, this B, and this angle is C. Now, since this is a right triangle, A plus B is 90-degree, then this is also a right triangle because that's how I have drawn this line. Then A plus C is also 90-degree. That is equal to A plus C. A cancels out. B is equal to C, right? That means this angle has to be the same as this angle, right? So this actually comes in handy many times. I have made use of that here. So something I just wanted to note. Each of the numbers a and b is a square of an integer. The difference a minus b is a prime number. Which of the following could be number b? Alright, so I can assume a is equal to m square, b is equal to n square. Then a minus b is m square minus n square, right? I have just substituted the value of a and b. Now that is m plus n times m minus n. So this factorization from m square minus n square to m plus n times m minus n. So that's very handy to remember. It's very easy to derive too. So let me just do that quickly. M plus n times m minus n. Let me call this y. So I'll just use the distributive property. So this is y times m minus y times n, y times n. I'll substitute back for y. So there is m plus n times m minus m plus n times n, which is nothing but m times m is m square plus n m minus m n minus n square. Again, I am using the distributive property, and this negative is because of this negative sign. N is same as m n, so this cancels out. This is m square minus n square. So this factorization of m square minus n square to m plus n times m minus n is very useful to remember. It comes very handy in algebra. That's what I have made use of here. All right, so a minus b is a prime number that is given to us. A minus b is prime number. So prime number is written as a factor of, as a product of two numbers. So let's take an example. Let's say 7. How can I write 7 as a product of two numbers? The only way I can write that is the number itself times 1. That is the only way. That is the definition of a prime number, right? So the factors of a prime number are the number itself and 1. So here, then the smaller of the two, m minus n, has to be 1, and this has to be prime, right? Then m minus n is equal to 1. This tells me that m is equal to 1 plus n. Okay, now m plus n, m is 1 plus n, so again m is 1 plus n plus n. So this is n plus n is 2n plus 1. Okay, so that is m plus n. However, m plus n has to be a prime number, right? So okay, so these are the given choices for b, and I know that b is equal to n square. That's why I have assumed. So what is n? N is going to be square root of b. Square root of 100 is 10. Here is 12, 16. So I assume that at this stage you know how to calculate the square root of a perfect square, so I will not go into the details of that. Square root of 900 is 30, and here it is 100, right? So that is those are the values of n. What is 2n plus 1? 2n plus 1. So 10 times 2 is 20 plus 1 is 21. So 12 times 2 is 24 plus 1 is 25. 16 times 2 is 32 plus 1 is 33. 30 times 2 is 60 plus 1 is 61. 100 times 2 is 200 plus 1 is 201, right? Now m plus n, which is same as 2n plus 1, has to be prime. It has to be prime, right? So this has to be a prime number. 21 is not a prime number, right? The factors of 21 are 7 and 3, right? So it cannot be a prime number. Again, 5 times 5 is 25, so this is not a prime number. 11 times 3 is 33, this is not a prime number. 61 is a prime number, okay? 201 is a multiple of 3, right? The sum of the digits, like 2 plus 1 is divisible by 3, so this number is divisible by 3. Then this is also not a prime number. So this is the only prime number, right? In that case, then D is the only possible choice. So the correct answer is D. In the 4x4 table, some cells must be painted black. The numbers next to and below the table show how many cells in that row or column must be black. In how many ways can this table be painted? All right, so we can immediately see that this column there cannot be any black. Similarly, this row there cannot be any black because of the number 0 there. Another thing we can notice that this row can have at most one black. This column will have at most one black. So if I put a black here, that satisfies for this row as well as this column. So there is one way, right? However, if I put the black here, that satisfies this row, but for this column, a black can go here or here. So there are two ways there, right? Similarly, instead if I put the black here, that satisfies this row. For this column, it can go here or here. So there are two possible ways. So it seems like there is going to be 2 plus 2 plus 1 is equal to 5 ways. But for each of those ways, you also need to make sure the other conditions. So let me just draw 5 duplicates that will make it easier to explain. All right, I have just drawn 5 duplicates of this and we will check each of these conditions. So first I'll start putting 1 here. Okay, so it is satisfied for this column as well as this row. So this is where I am starting. Now for me to satisfy here, I cannot put any more here, right? There is already 1. So it must go here, here, here. Those are the only 2 options. Similarly for this 2, it must go here and here. And that also satisfies 2 for this column, 2 for this column. All right. So if I put 1 here, there is only one way. Okay. Now, how about, I have already checked this. How about if I put 1 here? Okay. So I'm starting with this here. And for this column, I can put either 1 here or here. So in this cell, I'll check here. In this one, I'll check with this one. Okay. So again, I'm starting. This is where I'm starting. And for this column, for this, in this diagram, I'll start here. In this diagram, I'll start here. All right. So in this case, I cannot put anything more here, right? 1 is already satisfied. Here also, I cannot put anything else. So for this column to satisfy 2, I must put 1 here and 1 here, right? And then this is satisfied. Now for this to satisfy 2, I cannot put 1 more here because that will be 3, right? So 1 must go here. And here again, I cannot put because there is already 1. So if I fix this and this, there is a unique way. Similarly, let's try this. If I put 1 here and 1 there, so this row, this column is already satisfied. This row is already satisfied. Now for me to have 2 for this row, I cannot put 1 more here, right? Because this is already satisfied. So 1 must go here and here, right? So there is 2 for this. Now how about so this 2 is already satisfied, this 1 is already satisfied. I need 2 here. So this I must put 1 here because I cannot put 1 here because that will violate this row, right? So that is also unique. Similarly, you can also check the other 2. Start with 1 here and then assume that for this column to satisfy, you start one with here, and similarly start one here, and the other option is the other one can go there, and you can fill it yourself, and you will see that these are the 5 unique ways. So the correct choice is D. How many 5-digit positive numbers have the product of their digits equal to 1000? All right, so product equals 1000. So we need to factorize 1000. Let's try to find the factors of 1000. So whenever there is a power of 0, right, there is easy way to factorize. We know that 10 is 2 times 5. So 1000 is basically 10 to the power of 3 is 2 times 5 to the power of 3, which is 2 to the power of 3 and 5 to the power of 3. So we have basically 1000 is 2, 2, 2, 5, 5, 5 product, right? Okay. Now we have 1, 2, 3, 4, 5, 6 numbers. So we have to combine 2 of those and make one number, right? Now I cannot combine 5 with anything else because 5 times 2 is a 2-digit number, right? Okay, so maybe I can combine 2 and 2. So I'll make it 4. So then my factors are going to be 4, 2, 5, 5, and 5. Now, how many ways can I arrange this to make different numbers? So 5, 5, 5, they are the same. It doesn't matter how you arrange them. But 2 can go in the beginning, it can go here, it can go here, or it can go here. So that is 4 different ways. 2. Now, once I place 2 somewhere, let me just take an example. Let's say it goes after first 5, and then 5 and 5. Then I have to place 4, right? 4 can go how many ways? 1, 2, 3, 4, 5 ways, right? So for each of the placement of 2, I have 5 ways I can place 4. So 4 times 5 is 20. So basically there are 20 different ways I can arrange 4, 2, 5, 5, and 5, right? So at this point it's very tempting to choose B as the correct choice, but it is not. Now this would be a good time to pause the video and figure it out yourself. All right, hopefully you figure it out. So what is the trick? Also note that I can combine 2, 2, and 2. That makes it 8. But then I have 1, 2, 3, and 4 numbers only. But 1 is also a factor, right? So I can use 1. So basically my digits are now 1, 8, 5, 5, and 5, right? And similar to what we did here, I can first place 8. That will be 4 different ways, right? The 8 can go here, 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 or here. 1, 2, 3, 4. And for each placement of 8, 1 will have 5 ways to go. So 4 times 5 is 20. So this 20 and this 20 together are 40. Then actually D is the correct choice. Christina has 8 coins whose weights in grams are different positive integers. When Christina puts any 2 coins on one side of a balance scale and any 2 on the other side of the balance scale, the side containing the heaviest of the 4 coins is always on the heavier side. Right? So the side containing the heaviest of the 4 is always on the heavier side. What is the smallest possible weight of the heaviest coin? Alright, just like one of the previous examples, we will try to understand the concept with a simpler example, and then we'll extend it to this problem. So we'll start with, instead of 8, we'll start with 4 numbers. So let me call those numbers n1, n2, n3, and 4. And since they are different positive numbers, I can just assume that n1 is less than n2, is less than n3, is less than n4. Okay? Since they are different positive numbers, we can always order them. Now, the question is, what is the condition that the heaviest of these 4, which is n4, no matter how we pair, will be always on the heavier side? and the condition is going to be n4 is at least equal to or greater than the next two heaviest, n2 plus n3. Okay, so this is the condition. Let's try to understand this. First of all, let me show you an example that let me show you an example that will violate that. Let me say the four numbers are 1, 7, 8 and 9. Okay, in this case, if I pair 9 with 1 and these two together, so these two together are 8 plus 7 is 15 and 9 plus 1 is 10, right? So on one side I have 7 plus 8 and the other side I have 9 plus 1, right? But 7 plus 8, which is 15, is greater than 9 plus 1. So it is not always guaranteed that the heaviest coin is always on the heavier side, right? So it is not on the heavier side. So let's keep that in mind. So it is not always guaranteed. So I'm looking for a condition such that it guarantees me that the heaviest of the four, no matter how we pair, will be on the heavier side. And the condition is the heaviest has to be equal to or greater than the next two heavier ones, right? Now, why so? Let's say even if I pair the heaviest with the least heavy, so that is n4 plus n1, and on the other side I have n2 plus n3. I know that n4 is at least equal to this, right? And then I am adding another positive number, so it is guaranteed that n4 plus n1 will be n2 plus n3. So n4, so the side containing the heaviest element will always be on the heavier side, right? Okay, now of course this will be also true if I pair n4 with n3, right? Here I'm pairing n4 with even a bigger number, so this will be obviously true. Okay, so this is the concept. Let's keep that in mind and let's go to the original problem. We need 8 coins. So we need 8 coins and there are a few different conditions, right? We want the smallest possible weight of the heaviest coin, smallest possible, right? Okay, then so I want to, so let's find the first 4. Okay, now I want to add the heaviest with the smallest possible positive integer. So can I say that, is it fair to say that the n1 is going to be 1, that is the smallest positive integer, right? And the next two, can I take then the next two smallest, like 2 and 3? Okay, so what I did here is I chose n1 to be 1, n2 to be 2, and 3 to be 3, right? Such that I want to find n4, right? That guarantees that it will be always on the heavier side no matter how I pair. And that condition is, since I want the smallest n4, I will take equal to, I'll not take greater than. So n4 has to be equal to n2 plus n3. So n2 plus n3 is 5. Okay, now this guarantees me the condition that is given. So no matter how we pair, whichever side n4 is, like even if we pair with n1, so 5 plus 1 is 6, that is always greater than 3 plus 2, right? So the condition is guaranteed. So these are the first 4 coins that meet this condition. Now what will be the next one? n5. This has to be sum of these two, right? So that is 8, right? Now we can also check, even if I add 8 with the smallest possible smallest integer, that is 9, 8 plus 1 is 9, is always greater than, even if I take the next two biggest one, right? 5 plus 3 is 8. So 9 is greater than 8, right? And we can continue. So the N6 is going to be 8 plus 5 is 13, and 7 is going to be 13 plus 8 is 21, and 8 is going to be 21 plus 13 is going to be 34. 34, right? Okay, so that is it, right? We can actually double check, make sure that this, no matter how you pair an 8 with any of these numbers, right? Like you can pair this with the smallest number, so that is 34 plus 1, and that is, it is guaranteed that it will be on the heavier side, meaning even if you pair the next two bigger one, that is 21 plus 13, and we know that 21 plus 13 is 34, and I'm adding something else to this, so this will be always on the heavier side, right? So this is the smallest possible, you know, smallest possible coin, assuming there are 8 coins, right? Then C is the correct choice. 2021 balls are arranged in a row and are numbered from 1 to 2021. Each ball is colored in one of the 4 colors: green, red, yellow, or blue. Among any 5 consecutive balls, there is exactly 1 red, 1 yellow, and 1 blue. All right. After any red ball, the next ball is yellow. After red, the next is yellow. The balls number 220 and 202 are green. Okay. What color is the ball number 2021? Okay. Now, let me call G for green, red, yellow, and blue. And after red, the next is always yellow. That's what is given to us. So let me, I don't know how they are arranged, but let me just assume one arrangement. I know that red, after red, Y must come, and then blue. And I know that in any 5, there is exactly one red, one yellow, and one blue, right? In any 5, exactly one of this, and one of this. So first 5, I already have red, yellow, and blue. So there must be 2 green. So these are the first 5. First 5, right? Now if I take the next 5, red is missing here. So the red must come here, right? But after red, they are together, right? After red, yellow must come, right? So if you take the next 5, then again, I have exactly one red, one yellow, and one blue. And similarly, if I take the next 5, blue must go there, right? And then the next 5, green must go there, and the next 5, the other green, right? So if you notice one thing, whatever the pattern we start with, right? Whatever the pattern we start with, red, yellow, blue, green, green, or we don't know this pattern yet, that must repeat. That pattern must repeat, right? That pattern must repeat. Now we can definitely, experiment with a different arrangement. Let's say, for example, I just know that red and yellow have to be together, so I can start with a blue, and maybe red, yellow are together, or maybe even put the green here, put a green here, because I know that first 5, there has to be exactly one red, one yellow, and one blue, right? One red, one yellow, and one blue, and yellow is next to red, right? So that is the condition given. So you can start with this and then try to have the next 5. So blue must go there, and so on and so forth. So you will see that this pattern, right? If this is the pattern, it must repeat. So whatever the pattern is, it must repeat. Okay. So let's keep that in mind, and let's try to see if we can determine the pattern based on some other condition that is given. So it's given that the ball number 220 and 202 are green. So let me, so let's say these are the first 5 arrangement, right? And I know that if I can figure out this pattern, this just repeats, right? So the ball number 2 is green, so this must be green, right? And then it says 20 and 202 are green, right? So the pattern repeats every 5, right? So every 5 the pattern repeats. So what is 20? So that will be the end of fourth pattern, right? So in each pattern there are 5. So in 4 patterns there are 5 times 4 is 20. So that will be end of the fourth pattern. And at the end, and each pattern is the same, and that is also green, right? So green must go there, right? Now we know that R and Y, they are next to each other in this order, R and then Y. So this must be R, this must be Y, because they have to go together. The only thing that is remaining is blue then, right? So this is the pattern that continues, right? So we took care of the 220 and 202. So we can also verify that 202 is green, because 202, 200 is divisible by 5, and then first and second, this is first and then second, so it is green, right? So it's that is verified. Then we want, what color is the ball number? 2021. So 2021, what is the nearest number that is divisible by 5? 2020. So 2020 is divisible by 5, and so that completes the pattern. And then the first one, when we start is blue, right? Then the correct choice is D, the blue.